Now we shall see about measuring instruments. So one such example of measuring instrument is screw gauge. Measuring instrument is nothing but by using some of the instruments we can able to measure some objects which may be very small or thinner or tiny. So here we shall see about the micrometer screw gauge. A micrometer, sometimes known as a micrometer screw gauge, is a kind of device incorporating a calibrated screw which is widely used for precise measurement of components in mechanical engineering and machining. Screw gauge, which is an instrument, can be used to measure diameters of wires and thickness of steel plates to an accuracy of 0.01 mm. So this is an apparatus of how the screw gauge will be, and you can see how it is getting to be moved on, and here we have been placing the object and the diameter is calculated accordingly. So you can see here, by placing a small devices or stick or steel plates in this region, we can able to measure it by tightening and loosening up this thumb. So this is the overall apparatus of how the screw gauge will look like. Here we will be placing the object which is to be measured. A micrometer screw gauge is used to measure small length ranging between 0.10 mm to 25.00 mm. The micrometer scale comprises a main scale marked on the sleeve, you can find the sleeve here, and a scale marked on the thimble. So this is the region thimble called the thimble scale. So you can find the ratio over here. The ratio is nothing but the region which is used to tighten up and loosen up by placing an object. And this region is sleeve, and this is spindle, and this is the spindle face. You are seeing the micrometer screw gauge. If you wanted to measure a leaf, so we have taken a leaf and kept in a screw gauge. We know that screw gauge is an instrument used to measure the diameter of thin particles. You can parallelly check out the main scale over here, and this is considered to be the head scale, and this is the ratchet. We can able to tighten up and loosen up. So here we have kept an object, and this is the lock. Sometimes brackish error may occur. Brackish error is nothing but, in some experiments, it is seen that on reversing the direction of rotation of the circular scale, the tip of the screw does not start moving in the opposite direction. It may not start, but it remains stationary for a part of rotation. This is said to be called as brackish error. So the pitch of the screw gauge is the distance moved by the tip of the screw when the head of the screw is rotated. So you can see here how to rotate the screw gauge. In order to find the pitch of the screw gauge, we have a formula. Distance moved by thimble on the main scale divided by the number of rotations. Least count of a screw gauge can be calculated by pitch divided by number of divisions on the circular scale, and the determination of screw error of a screw gauge. So you can see the zero error, the positive error over here, the circular scale division coinciding with reference to the main scale that has been indicated over there. In terms of negative zero error, we have a depiction. Observed reading equal to main scale reading plus coinciding circular scale division into least count. Once after observing the reading, we can just check and reset. This is nothing but a depiction which has been done in GTech laboratory in order to find out the observed reading. For measuring the diameter of a wire, the observation which has been done with a least count of 0.01 millimeter and a zero error of plus 0.05 millimeter. So this is nothing but the observation which we have taken in the GTech laboratory. So this is how the screw gauge will be. Screw gauge is used to measure, which is an obvious fact, thickness of various steels or gauges or diameter of disc cylinders or thickness of plywoods or some of the objects which has been used to measure screw gauge. So the difference between one division on the upper scale and one division on the lower scale is 0.5 millimeter. When taking a reading, the thimble is turned until the object is gripped very gently between the anvil and the spindle. So you can see here, so this region is anvil and this region is spindle. You can find a lock which has been mentioned here. And this is the sleeve with main scale reading, and this is the ratchet knob. The ratchet knob is then turned until a click sound is heard. The ratchet knob is used to prevent the user from exerting under pressure. The grip on the object must not be excessive, as this will affect the accuracy of the reading. Readings on the micrometer screw gauge are as follows. So the first step is, the last graduation showing on the main scale indicates position between 2.0 mm and 2.5 mm. Thus the reading on the main scale is rated as 2.0 mm. So you can find here. Let us see how to take a reading in micrometer screw gauge. Reading of a micrometer is calculated by adding up the reading of the main scale plus the reading of thimble scale. You can see the range which has been started from 0 and so on. So this is the main scale reading and this is the reading of thimble scale. The reading of the main scale has been noted as 5.5 and the reading of the thimble scale is noted as 0.30 mm. So once after finding the reading of the main scale and the thimble scale, we need to add up in order to get the reading of the micrometer screw gauge. So by adding these two, we will be getting an answer of 5.80 mm. In order to find the reading of the micrometer screw gauge, we have the main scale, vernier scale and the reading which has been observed once after identifying these things. It's an example which has been done in the GTech laboratory. So the main scale reading is 5 mm, which is over here, and the vernier scale reading over here is, so we need to understand the difference from 0 to 5, from 5 to 10. The interval is 5. So we need to mention the vernier scale reading as 0.07 mm. Since it has been touched this region, so the value is 0.07. By adding up these two, we will be getting an answer of 5.07 mm. Similarly, if you check out this one, the main scale reading will be, so this is the main scale, the reading is 5.5 mm. You can see here, and the vernier scale reading is 0.07 mm. By adding this one, we will be getting an answer of 5.57 mm. So this is all about how to take a reading in a micrometer screw gauge. After that, the reading of the micrometer screw gauge is the sum of the main scale reading and the thimble scale reading, which we already knew and we have seen. So for the depiction of example, so this is considered to be the main scale reading value, which is 2.0, and the thimble scale reading value is 0.22. Altogether, if we sum up, we will be getting an answer of 2.22 mm. And after that, the reading of the thimble scale is the point where the horizontal reference line of the main scale is in line with the graduation mark on the thimble scale, showing that this is to be the 22nd mark on the thimble scale, thus giving a reading of 22 into 0.01 mm, which is equals to 0.22 mm. So in terms of micrometer screw gauge, we have a negative zero error. The horizontal reference line on the main scale is in line with the third division mark, that is below the zero mark of the thimble scale. So the zero error has been calculated as minus 0.03 mm. So this is one such depiction of how to find the negative zero error. You can also find some depiction of micrometer screw gauge.